Hey guys, this is Ms. Owens. We're looking in your Intro to Chemistry lab notebook on page 8, and we're going over Chem 4, changes in state. So we're learning about those physical properties of different types of substances and how they are found in states of matter, of solid, liquid, and gas primarily. And today we're just looking at how they can change from one state to another. So when we're changing from a solid to a liquid, this is called melting. So melting is when you have a substance that has the atoms, those particles all packed closely together in the solid form, get heated up to the point where you reach the temperature that's referred to as the melting point, and those particles are going to begin moving around, and they actually can begin to flow freely and take up the shape of their container, and that is when it's considered to be a liquid. So from that increase in temperature, substance is going to absorb enough heat energy to where it melts and it goes from a solid to a liquid. Same thing as we see here with ice. We know that ice is just water that's frozen. It's water that's in the solid state. So when it heats up, it's going to melt and then it becomes a liquid, but it's still water no matter which way you look at it. So it's still something that is physical. It's retained its chemical identity. It's just changing in state. So that is specifically a physical change, not chemical. Don't get that confused. Changing from a liquid to a solid is going to be called freezing. So if you've ever made those little icy pops or Kool-Aid pops during the summertime, you may have mixed up some Kool-Aid and put in a little ice cube tray and put a toothpick or a popsicle stick in it. So you've actually frozen that water or frozen that Kool-Aid into a solid. You've turned it from a liquid to a solid by decreasing the temperature. So you take these molecules, like you have in the picture here, this liquid water. So you have all those little molecules that are moving around nice and happy and flowing freely. And as they decrease in temperature, they get into more of a rigid structure. Specifically for water, since it's crystalline, it's going to get in this nice little crystallized pattern. And that pattern is going to lend itself to snowflakes. Changing from liquid to gas. The change from a liquid to a gas is called vaporization. Anytime you see this word vapor, it's referring to something in the gaseous form like water vapor. So changing from liquid to gas is vaporization. There's two types of vaporization, and those are evaporation and boiling. And the difference between those is just the location at which the vaporization occurs. So evaporation is going to only occur at the surface of the liquid. So we have some fog here that is occurring, and it's not what we think of as typical fog, that's our stratus clouds, but it sort of looks foggy. This effect comes from the evaporation on the surface of this water, on the surface of this lake here. So just those water molecules on the surface are getting heated up to the point which they will turn into a gas. And when you have boiling occur, you have convection currents that take place. Boiling is going to occur from the surface of the liquid, but on down to the bottom of the liquid as well. So in this example, this is basically showing you if you were boiling water to make spaghetti or tea or something else. So we have like a burner basically on a stovetop here. So this gets heated, and we know that heat rises. So it's going to initially heat up all the water molecules at the bottom, and as they get heated up, they become less dense. So they're going to rise up to the surface. And then when they come in contact with the cooler air at the surface, they're going to begin cooling down, and so they will sink. And this is how you get a convection current created. So those molecules are sinking because they're cooler, but then they get heated up again and become less dense. So they rise up, become more dense because they're cooler, and sink, and so on. So that's what ends up with this nice little convection current that helps boiling to take place. And if you've ever boiled water before, you know that the bubbles are going to mostly start at the bottom of the pot that you see here, and then you start seeing bubbles kind of move up throughout the whole substance, and then eventually you're going to see this steam that gets released as the water is vaporizing. Condensation is something you probably have heard about in reference to the water cycle. So we know in the water cycle you've got evaporation, condensation, and precipitation. And during condensation in the water cycle, we have cloud formation. And what causes that to occur is the water vapor losing thermal energy, giving off thermal energy. So it's cooling down and it's changing from a gas into a liquid. So it's going from being that really hot water vapor to liquid droplets of water in the cloud, which eventually accumulate and cause it to rain as those droplets get heavy enough. So that can occur in other places as well. You may have seen that in your house on windows during the wintertime, especially when you're running the heat a lot and it's really cold outside, and on a drink like your McDonald's cup or this plastic bottle we have here. It looks like the glass or cup is sweating, but it's not. It's actually where you have that really cold liquid that comes in contact with the warmer air around it. So that cold liquid is going to cause the water vapor, those molecules in the air, to cool down, and as they cool down, they turn into a liquid, and they're going to cling to the sides of that substance. And so that's when you have these nice little droplets here. So that is condensation occurring. And the last one is sublimation. So sublimation is really cool. It's really cool. See, it's a pun. So that's when you have, like this example, dry ice. So dry ice is basically frozen carbon dioxide. It's carbon dioxide that is so cold, it's formed into a solid. And because this dry ice is so cold, when you expose it to room temperature, it actually turns straight into the gaseous phase. It does not melt into a liquid. So because the carbon dioxide is so cold, and it has to be kept so cold for it to be a solid, when it's exposed to this room temperature air, it immediately heats up, and it heats up so quickly that it is turning into a gas. It's not melting at all. So that's what you see that's being released here. You have that dry ice releasing all this kind of foggy appearance, and that's the carbon dioxide turning into a gas, and it eventually will dissipate. So it's used a lot in movies and at Halloween time for sort of foggy effects. Thanks, guys. Have a great day.